Hello everyone, my name is Jansi Kalpala. Today I am talking about the linear regression and the subject which is GRC 605. The agenda for this presentation is linear regression testing and taking the sample data, analyze the result, important takeaways and closing. The linear regression defined as linear regression is a basic type of predictive analysis. The common usage of this regression is to study and find the relationship between two or more continuous variables. A scatter plot is the most helpful tool in determining the strength and relationship between the two variables. Here, the formula for the linear regression is y equal to b0 plus b1x. For this presentation, the research background we have done is the data is collected a sample of 150 people and the people who are working in Midwest USA, and we asked the questions about the income and finding the other variables dependency with the independent variables. Here the linear regression test was conducted between the variables of debt and income, savings and income, stocks and savings. In this slide, we are talking about the first regression test, which is conducted between debt and income. The hypothesis test, which is defined here, the dependent variable is debt and the independent variable is income. And the null hypothesis is like the regression coefficient is 0, that is beta equal to 0. The regression coefficient not equal to 0, that is beta not equal to 0. Using the PSPP, we conducted the linear regression test. Here the variables between the income and debt. Here the r square value equal to 0.0, the beta value equal to minus 0.05, p equal to 0.535. Here, if you see the results, the p-value is greater than alpha, so the test is failed to reject a null hypothesis, and the confidence interval has 0 between the limitation. The regression test, which is conducted between the savings and income. Here, the dependent variable is savings and the independent variable is income. The null hypothesis, again we define beta equal to 0 and alternative hypothesis beta equal to non-zero. And when we conducted the PSPP regression testing, so here also the beta value we got at 0.91 and r square equal to 0.82 and p value equal to 0.00. So if you see here, p is less than alpha and the confidence interval between these two variables is 0.09 and 0.11, and there is no zero lying between the confidence intervals, so we reject the null hypothesis. The third regression test is conducted between the stocks and savings. Here the dependent variable is stocks and the independent variable is savings. The null hypothesis we defined as beta equal to 0 and the alternate hypothesis is slope of the regression coefficient, which beta is equal to non-zero. When we conducted the hypothesis test using the PSPP, the values which we obtained is beta equal to 0.28 and r square equal to 0.07, p equal to 0.000. Here if you see the results, the p-value is less than alpha and the confidence interval is lying between 0.07 and 0.25. So if you see, there is no zero lying between confidence interval, so hence we reject the null hypothesis. The important takeaways are, using the PSPP we can easily calculate the r square, beta value and the confidence interval. This is the most useful tool for all these lessons we learned. Regression models predict a value of the y variable and given dataset values of the x variables. So this is the prediction method we used, which is called interpolation. Rejecting and or considering the null hypothesis based on the p-value and the confidence interval. Last one, the interpolation and the extrapolation methods are used to make predictions. The references which I use for this course is like the YouTube video for the statistics basics, which is by the Brandon Falls, and the other video which is our curriculum video, the statistics linear regression in PSPP by Dr. Stephen Hess. That's all for this presentation, and this is fun learning the statistics using the PSPP, and I enjoyed throughout the course. Please post your feedback and comments, and thank you all, and I wish you all the best for all of my classmates. Thank you.